This pie chart shows a data point from a recent MIT study. 95% of enterprise AI projects fail to produce any measurable business impact. The AI models themselves work perfectly fine. The collapse happens here, during the deployment phase, when companies try to force those models into their existing systems. To fix this exact failure point, tech companies rely on a specific role, the forward-deployed engineer. They operate using a rigid 4-phase core loop: scope, build, deploy, and prove. Let's apply this loop to a real-world scenario. Imagine a hospital executive approaches you with a highly ambiguous request. They want to use AI to speed up their emergency room. By pushing that vague request through the 4 phases of the forward-deployed loop, we can transform a broad idea into a durable, finished AI product that actually works in production. The first step is the scope phase. You don't sit in a back office and start writing code. You fly on-site, map the hospital's daily workflow, and narrow that down to one specific bottleneck, turning a vague request into a concrete specification, like extracting triage notes directly from doctors' voice memos. Next, you build a minimum viable product. But at this stage, you are entirely isolated from the hospital's live servers. You build this prototype using fake synthetic data to safely test your concept. Stop and think for a second. Before you spend weeks building the real version of this tool, how do you objectively measure whether your AI logic is actually outperforming the current human triage process? You establish strict evaluations, or evals. Setting up these rigid quality checks right now prevents you from building a highly functional system that fails to solve the client's actual problem. Look at this architecture diagram. This represents phase 2, build. Here, you write production code to create agentic logic, bridging large, off-the-shelf APIs with the specific tools the client needs. This is where we strip away the synthetic data. Your logic is now wired directly into the hospital's live, highly complex internal databases. Then we hit phase 3, deployment. Moving your code off a local machine and into live enterprise infrastructure introduces immediate friction. You immediately run into strict security firewalls and tangled legacy data pipelines held together by duct tape. You might find yourself operating on completely air-gapped networks with zero internet access, or fielding 2 a.m. emergency calls when a critical piece of that fragile infrastructure inevitably breaks. Operating inside this restrictive, chaotic environment is exactly what separates a forward-deployed engineer shipping durable enterprise software from a standard developer building offline demos. This timeline illustrates the final phase, prove. Your job does not end when code is pushed to production. You stay embedded, debugging and optimizing the live system until you hit a specific, measurable business metric, like driving ER wait times down by 15%. Hitting that concrete metric is the only accepted definition of done. You own the final outcome, whether that means securing a multi-year contract renewal or proving a direct revenue lift. Let's look at the complete cheat sheet to lock this in. Scope the true bottleneck using fake data and strict evals. Build the real logic. Deploy into messy, secure systems, and prove the result by staying on site until the metric is hit. Mastering this 4-phase loop takes you from writing isolated code to solving high-stakes enterprise bottlenecks. Executing this process is why these engineers command the highest compensation in the entire AI industry.